Hello everyone, welcome to the course of Deep Learning. So I am one of the TA for this course and I'm currently pursuing my PhD from Indian Institute of Science in Representation Learning. So I will be one of the TA for this course and every week from Saturday 3 to 5, this session will be taken by me. So we will be solving the week assignment problems that you have any questions, any doubts in the content of a week. So you are feel free to ask any question which you have. So and as this course is a very beginner friendly course, so I'm assuming that many of you might be coming from a different background. So some of the concepts or some of the things might be new for all of you. So for this week, I have planned to cover the week 1 assignment as well as week 0 assignment. So we will be solving the questions related to this week and questions and the doubts which you have in the respective week content. So let's start with solving some of the problems. So firstly, we will be starting with the week 0 problems. So I know that it isn't compulsory, but I will be giving you the important steps to solve the problem so that in the end solution, you can get it on your own that how to solve the problem, basically. I am not going to solve the whole problem, but I'm going to highlight the steps which you need to solve the problem, as these are the prerequisites for the course, which you should be familiar with. So let's start. So week 0, problem 1. So it's about we have been given a matrix and we need to find the product A transpose A. So basically, we have been given matrix A, which is of the following form, that is 1, 2, 0, 3, -1, and 4. So basically, it have two columns, 2 rows, and 3 columns. That is the size of this matrix is 2 cross 3. And the question asked is that we need to find A transpose A. Okay. So first of all, A we have been given, and we need to find what is A transpose A. As there are 4 options. Okay. So, but what's the shape will be A transpose A. So you can directly cancel 2 of the options and try to figure out that which is the correct option. So as A transpose is of size 2 cross 3, A is of the size 2 cross 3, and A transpose is of the shape 1, 2, 0, 3, -1, 4. That is 3 cross 2. So whenever you multiply a 2 matrix, that is A, B. So if A has a shape of m to the power n, and B should also have the shape of n to the power p, n cross p, where n in the first case is the number of columns and n in the second case is number of the rows. So the product of these two AB will be belonging to the we know A, the shape that is 2 cross 3. We know the A transpose that is 3 cross 2. And we need to find you can guess what will be the shape of this A transpose A will be. So A transpose A will be having a shape 3 cross 2, and which is second one is 2 cross 3. So which implies it will be having a shape of 3 cross 3. So option A and B is directly eliminated. So we have been remaining with two more options. Now to find A transpose A, we can write the matrix as 1, 2, 0, 3, -1, 4. That is 3 cross 2. The A matrix which we had been given is 1, 3, 2, -1, 0, 4. That is 2 cross 3. Now we need to find the product of A transpose A. So as you already guessed, it will be of the shape 3 cross 3. So how do we carry out the matrix multiplication? So you need to multiply each row of the first matrix with each column of the second matrix. So that is how we calculate the matrix multiplication. So in this case, 1 cross 1, it will be 1 cross 1, that is 1, plus 3 cross 3, that is 9. The second element, the same you need to follow out. So let me write it in a bigger matrix way. Yeah. So it will be 1 cross 1 plus 3 cross 3. Okay. The second element of this will be 1 cross 2 plus 3 cross -1. The third element will be 1 cross 0 plus 3 cross 4. Okay. So this is that first row of the product of A transpose A. The second row, we need to follow the similar procedure as we did for the first row, that is 2 cross 1 plus 2 cross 3. Now the next element will be 2 cross 2 plus, no, here it will be, sorry for the mistake. So 2 cross 1 and -1 yeah, -1 -1 cross 3. The second element 2 cross 2 -1 cross -1. The next element similarly will be 2 cross 0 plus -1 cross 4. Now the third row, we need to follow the same procedure. That is, it will be 0 cross 1 plus 4 cross 3. The next element similarly 0 cross 2 plus 4 cross -1. The next element will be 0 cross 0 plus 4 cross 4. So if you just simplify it, it will be coming 1 plus 9, that is 10, 2, 2 minus 3, that is -1, and the next element will be 12, 2, 2 minus 3, that is -1. Here it will be 12, then here it will be 5, here -4, and -4 similarly, and here we are gonna get 16. So the answer will be basically option C in this first question. So I hope it's clear that how you need to solve the problem. it's all about the matrix multiplication, and you need to check whether we can multiply A cross B. So the columns of the first matrix should be equal to the row of the second matrix. And the outer product we'll be getting as a row of the first matrix cross the column of the second matrix. So that's how it works. Now, any doubt you are having, you can just ask. Okay, so let's move on to the next question. It's pretty much easy question that if you're familiar with the concept of polynomial, how you substitute the value in that and get the point where means for the point value, then here you need to do the same thing but with the matrix. So basically the second question, we have been given a matrix that is 2 cross 2 square matrix 1 2 4 minus 3. Okay, and we have been given polynomial, and we need to evaluate that at A, which is a matrix. So f of x is x square plus 2x minus 11. What we need is f of A. Okay, so A we know. So to calculate f of A, it's basically equivalent to A square plus 2A minus 11 into identity. So just remember the convention that whenever you are we are having a matrix, identity is basically 1 0 0 1, means all element ones along the diagonal. So this is what we call identity of shape 2 cross 2. Okay, so basically we need to compute a square 2a then minus 11i, where I is identity element, identity matrix. So let's calculate first of all a square, which is a into a cross a basically. So you can write it as 1 2 4 minus 3 and 1 2 4 minus 3. So basically if we do the matrix multiplication, it will be 1 plus 4 to the 8 as what I did in the last question. And I am hoping that you all are familiar with simple matrix multiplication as it's the prerequisite for this course. Then 1 into 2, that is 2 minus 3 to the 6. 2 1 ja 4 and minus 3 into 4 minus 12. Okay, 4 2 ja 8 plus 9. So if you compute it, you'll be getting it as 9 minus 4 minus 8. 8 plus 9, that is 17. So let's cross verify once. 1 cross 1, 1, 2 cross 4, 8. So totally 9. Yeah, it's correct. 1, 2, 2 minus 6, that is minus 4. It's correct. 4 cross 1, 4 minus 12. Okay, yeah. So 4 cross 4, 4 cross 1, 4 minus 3 cross 4 minus 12. If you add this two term, you're gonna get minus 8. Yeah, it's also correct. Then 4 cross 2, 8. Minus 3 cross minus 3, that is 9. 8 plus 9, that is 17. So let's now find f of a, which is a square minus plus 2 times a minus 11 times identity. Now it's just basically matrix addition, and subtraction. So a cross I have calculated already for you. 2a is just you need to multiply each of element of a with 2. Then you are gonna get the 2a matrix. So it will basically 2, 4, 8, minus 6. And minus 11 identity is just simply minus 11, 0, 0, minus 11. So you can just calculate and just get the answers. So I'm not gonna solve this everything for you. You need to do some of the step on your own. But I have given you the way that what you need to do. So the main thing here was this 11. Here now my matrix, this is A, but here we don't have anything. So you can assume it to be x0. Okay. And x0 means which imply a0 is always identity. So just remember, if a is my square matrix, then a to the power 0, you can assume it to be identity. That's it for solving this problem. Now let's come back to third question. So it's all about probability. So I assume that you know the basic probability, that just simple thing you need to know, number of favorable outcome divided by total number of outcome. That's in the simple word. So let's do the problem 3. So we have been given bin A containing a 5 lead balls. So okay. So basically we have bin A, we have bin B. Okay. B given. In A, we have 5 red ball and 3 blue ball. In bin B, we have been given 3 red ball and 2 blue ball is given. Okay, so this is what is given in the question. Now they say that they draw a random ball from each bin. Just read the question properly. So they say that from each bin, they have drawn a random ball. So it can be either red or blue. Okay. Now we need to find a probability. Okay, 2 ball is drawn. That is experiment E1, which is the ball drawn from bin A, which consists of 5 red and 3 blue. And bin 2, E2 is the event denoting the uh, drawing a ball from bin 2, out of which 3 are red and 2 are blue. Okay. So basically, we need to find probability of 2 balls were drawn at random. Okay. So there arises a 2 question, means 2 probabilities will be arising in this question. That is 2 cases. Case 1, which is E1 is red and E2 is blue. This is the event we want to find. That is one of them is red, one of them is blue. Okay. And second case, where my event E1 is blue and E2 is red. So we need to sum of the probabilities because these two events are disjoint event. If we just sum it up, you'll be getting the required answer. What we want. So okay, just let's calculate it. So in case one, okay, probability of drawing a ball red from bin one is probability of drawing E1 equal to red is 5 divided by 5 plus 3. See, 5 is the number of favorable outcome. That is, we want the red ball. Okay. And 5 plus 3 is the number of total possibilities we would have done. So which is equivalent to 5 by 8. Similarly, probability of getting E2, okay, is equal to blue. Similar thing what we did. That is, this time we need a blue. So it will be 2 divided by 2 plus 3. Okay. That is 2 by 5. Now each one of them is an individual, means each one of them is a disjoint event. Disjoint event means selecting a ball from E1 does not affect, means basically they are disjoint, means E1 intersection E2 is 5. What does it mean? That the disjoint as well as independent event. That is, if I draw red balls from on bin A, it does not gonna affect the probability of having a ball B, another ball, whether blue or red, from bin B. So they both are independent event. So if you want, in the case one, the probability of drawing E1 is equal to red and E2 is equal to blue is just simply a product of each one of them. Just remember each one of them because my events are probability of E1, E2 is equal to probability of E1, probability of E2. E1 and E2 are independent events. Okay. So it is just probability of drawing E1 equal to Z multiplied by probability of E2 equal to blue. Okay, so in the first case, probability of E1 equal to Z, E2 equal to blue is 5 plus 8 multiplied by 2 by 5. 5 to the 10, 8 5 ja 40. This is just simply 1 by 4. Okay, so that was the first case. Let's take a case 2. Okay. In the case 2, we need to follow the same step, but this time we need to have blue ball from the bin 1, and a red ball from the bin 2. So probability of E1 is equal to blue is simply 3 by 8. Just remember the sum of this probability should add up to 1. Okay, because our sample space consists of red and blue ball, we just have a 2 events, and the probability of sum of 4 sample space is 1. Okay, so that's the fundamental thing you already know about. Similarly, probability of E2 is red. You know it's 2 by 5. Here it will be 3 by 5. So similarly, probability of E1 equal to blue and E2 equal to red. Again, by the same argument, both of them are independent event. That is, occurrence of one event doesn't affect the occurrence of second event. Just remember this thing. Okay. So just probability of E1 is equal to blue. Probability of E2 is equal to red. That is 3 by 8 plus 3 by 5, which is 9 by 40. This was 1 by 4 we got in the equation 1. Second, just now probability of getting red or blue ball, red and blue ball of the event in which we draw one ball from the bin 1 and one ball from the bin 2. It just equal to probability of E1 is equal to red, E2 is equal to blue, plus probability of E1 is equal to blue, E2 is equal to red. Just remember this point, okay? As because this are only the two cases. Then it's equivalent to 1 by 4 plus 9 by 40, which if you do the calculation, it will be 19 by 40. Okay, so that's option D in the question. Now, totally we have 10 questions. Now we have solved 3 of them. So let's go on the next question. Question number 4. So it's asking what's the probability of drawing out hearts or queens from a well shuffled pack of 52 cards in random. So you should know about a deck of cards. So basically, we have a deck of cards, okay, in which total number of cards are 52. Okay, we have a 4 division of cards. So as many of you are not familiar with what the deck of cards are, basically means how the means what are different decks or the elements cards we are having. Just type decks of card in Wikipedia. Okay, so it's a standard deck. We have a total of 4 suits. Okay, we have a suit 1 of clubs, the suit 2 of diamonds, suit 3 of hearts, and suit 4 of spade. Okay, and each suit contained one king, queen, and there are 4 deck. So 52 are the total card. 52 divided by 4 if you do, there are 13 cards in each suit. Okay, is that clear? Okay. Now, each suit contain one king, one queen, one jack. Okay. So this are all card face card. So they have total of 4 king, 4 queen, 4 jack. Okay. So this is all the information you need for solving the problem, basically. So if you don't know how this cards, basically, if you want to know more, just type on the Wikipedia, you will get how the different suits, how many are different elements there. Okay. So what's the question asked? Probability of we need to draw a card. Okay. So let's denote the event as E, and we want basically a card out of hearts. That is, it should be coming out of this 13 or queen. Okay. So you know that there are total 4 queens we have. And total there are 13 hearts card we have. Okay. And there is one queen, which is heart, which is common to both of them. Okay. When both, which is heart and which is queen. So total we want basically heart or queen. Basically, the probability you need to get is probability of getting heart or queen divided by total number of cards. Probability means total number of, basically this is total number of heart or queens, number of divided by total number of cards. So this will be probability of the event which we want to calculate in the question. Total number of cards we know is 15. Total number of heart is 13. And the queen, as I mentioned, we have a total 4 queen, but there is one queen which is a heart, which we already have counted. So it will be 3. So it is 16 by 52. If we just simplify it by 4, because 4 is the common divisor of 16 and 52, that will be calculating as a 4 by 13. So that will be the answer. So I hope this point is clear. So many of you might not be knowing about the deck of card and all. It's fine. Just go into look into Google and Wikipedia basically. The question is easy once you understand that what we want to calculate. So in simple word, to calculate any probability of an event E, you just need to find the number of events, number of favorable event in which you want. In this case, it was the heart or the queen, divided by total number of possibilities. Total number of events. Okay, so this is a simple probability. So if you have any question, feel free to ask. Now, let's coming back to question 5th. So it's about vectors, and I hope you are familiar with the vectors. So question is that we have been given two vectors P and Q. Okay, with magnitude, with mod of, and this denotes the magnitude. Okay, magnitude is √3 and magnitude of Q is 2. And we have been given a dot product. Okay, dot Q is equal to √6. And the question is about finding the angle. So you know basically that dot product, you can write it as mod P mod Q cos theta. Okay, so this is the formula only you need to solve this problem. Okay, so you already know this quantity, which is √6. You already know this quantity. So the cos theta, you can write it as √6 divided by √3 cos 2. So basically √6 you can decompose that √3 √2 cos 2, which is 1 by √2. So for what angle you get cos theta as 1 by √2, so which implied it's just simple 45 degree. Because if you don't remember the exact that how it's 30, 60, 45 something, the simple thing is simple rule out. In the 45 degree, my both sides are equal and this is √2. So the cos theta in that case is cos theta is 1 by √2, which is this base by perpendicular. Okay, so any questions? This is 45 degree. So these are very basic problems just to for you just to get familiar, because if you know all these concepts, it's will be easy for you to learn the deep learning concepts. Otherwise, first of all, brush up the concept, then watch the lecture material basically. So you need to know about the normal vectors, normal differentiation, integration, normal metrics algebra. So these are some prerequisites you need to have. I'm and these are pretty much the things. That's it. Okay. So let's coming back to next question. It's about differentiation. Okay. So I hope you all are means you might be familiar with normal differentiation. So let's solve this problem. Problem number 6. So normal rules you might be known that differentiation of log x is 1 by x and all. So that I assume that you already know. So let's solve this thing then. We have been given a function u, which is dependent on variable x and y. That is, it is a function of x and y. So log 2x squared plus y square. And this quantity is well defined. It's because okay, because square it can't be negative, because log negative you can't calculate it. So whenever the problem is there, first of all see whether it's defined properly or not. Okay, whether you can solve it or not, basically, because otherwise lot of uh, corner cases you might able might miss basically. Okay. Question is about finding dou u by dou y. So this is called partial derivative. So it's the concept of multivariable calculus. As I mentioned, you should know that how to differentiate with multiple variables. If you know one variable, it's very easy for second variable as well. You just need to assume the second variable as a constant and need to carry out the same differentiation what you did. So in this question, for calculating dou u by dou y, so this is required as a dou u by dou y. You just need to know, you just need to keep x as a constant. That's a simple thing. So basically keep x constant. Okay. So that's what you need basically. So let's calculate it. So dou u by dou y. So differentiation of log by chain rule. Just remember, we will be using the chain rule. And chain rule is just log of some function f of x. You can write it as first of 1 by f of x, derivative of f of x, like that. Okay, so it states that basically u, if my function is u and it's a function f, which is in turn a function of g of x, something like this. Okay, then du by dx, you can write it as f dash g of x, then multiplied by g dash of x. So this is what chain rule. Okay. So to calculate dou u by dou y, we need to calculate dou by dou y of log 2x square plus y square, which is just simply 1 by 2x square plus y square. Just remember, just forget whatever the expression given in the log or something, because we just need to take a derivative of log. That's what the chain rule tells us. Then we need to calculate dou by dou y of 2 of x square plus y square, which is just simply 1 over 2 of x square plus y square. As I mentioned, whenever you are taking a partial derivative, keep the one constant means as it was a function of x and y, if you're calculating the partial derivative with respect to y, keep x constant. It's a constant. So x is constant. So you just need to multiply as the derivative of y with respect to a constant is 0. So this will be 0. It will be 2y. So the answer for this will be basically 2y, 2x square plus y square. So basically, this question just told about partial derivative, where you differentiate with respect to one variable in the multivariate setting, keeping all the variables constant. That's one thing. The second thing is chain rule. So these are the 2 points, and you should have a strong grasp of this concept, because in deep learning later in the course you will be doing the back propagation, that is optimization of neural network. So at that time it will come very handy. Okay, so just have a strong grasp of this question. Let's come back to question 7. It's about finding the determinant of A. Okay, so I hope you are familiar with how to calculate a determinant of A. So if you are not, just I will be giving the step. You can just carry it out. Okay, so A we have been given as 2, 1, minus 1, minus 3, 2, minus 2, 4, minus 3, 5. Okay, this is the question given. Simply, it's of 3 cross 3. Now you need to find determinant of A. Okay, so it's just simply 2 times determinant of 2 minus 3 minus 2, 5. Then minus 1 determinant of minus 3, 4, minus 2, 5. Then minus 1 determinant of minus 3, 4, minus 2, minus no plus 2, minus 3. So the concept is that if you are expanding along the columns, okay, take one element, remove that particular row and particular column, and write the remaining determinant, means the remaining matrix. So that's what I did. Okay. So now it has been reduced to calculating 2 cross 2. Okay. You need to know the concept that determinant of 1 cross 1 is just 2. Okay. Now again, you need to expand this in the similar manner what I did, and just calculate the determinant. And if you remember here, the minus is coming. That's because of minus 1 I plus j, where I denotes the row and j denotes the column. So here in the first thing it was 0, 0. So that's why the minus 1 to the power 0, it's 1. In the second case, it was 0 plus 1, so that's why minus 1 is coming. Here it was again even. So it just plus minus like that goes on. So just brush up the concept from 12th standard. Okay. Now let's come back to question 8. Okay. Question 8 is again about calculating the differentiation we need to carry out, but it's one variable, so that's pretty much easy, I guess. So we have been given y is just a function of 4x cubed plus 1 divided by x. The simplest way is it's a form of numerator by denominator. So there's product means differentiation rule whenever you have a form of p by q. But for this question, there is another simple way of carrying it out. Just separate the terms. So you can write it as 4x squared plus 1 by x. Okay. So Now each individual term we have over each individual, which is easy to carry out. So dy by dx, for this question, you need to know that derivative of x to the power n with respect to dx is just simply nx n minus 1, where n is an integer. Just remember this thing, okay? So it will be just simply 8x, okay? Now, how to calculate x to the power minus 1? It's just as simple. So whenever you have x to the power minus 1, okay, you need to it just add up, basically just uh, add it up, basically means x to the power minus 1, it become x to the power minus 2. So it's just differentiation of x to the power minus n divided by dx. Whenever it is of this form, you can write it as basically x to the power minus n plus 1 divided by minus n. Okay. So in this case, we have been given x to the power minus 1. So basically x to the power minus 1 plus 1. And as I mentioned, minus 1. So basically it will be 8x minus, because minus will be come from here, x minus 2. Okay. So I hope this is clear. If you are not getting it, just go and revise the concept of differentiation. Okay, because that will come in very much handy. Now, two more questions are remaining. Okay, let's move on to question 9. Okay, it's about finding the rank of a matrix A. We have been given matrix A, which is just basically 3 cross 3. This time we have 3, 1, 2. Okay, 2, 0, 5, 1, 2, 3. It's 3 cross 3. The rank of a matrix, you can define it as, so for example, what is this matrix does? Whenever you multiply a vector with 3, so this matrix basically maps from R3 to R3, okay? Where R3 is my space, okay? 3D space in this case, especially, okay? So it's taking a vector. What does it mean? It's means it's take a vector from X and it's multiplying to some vector Y, where x and y both belongs to R3. So the rank it basically means that the dimension of the space where it is mapping. Okay, so you can decompose after multiplying with the matrix A, it maps to the space. Okay, what's the dimension of that space? Because this R3, it's not necessarily that it is means this mapping is wholly a R3. So it might map to the its subset, which is R2 or R1. Okay, so there will be a cases. And the rank can never go up, means rank of a matrix A is always upper bounded by, in this case, n cross n is there, it will be always bounded by n, where A belongs to R n plus n and is over bounded by 0. That's the means not a tight bound, but yeah, it's a bound. So can anyone tell me that how we can proceed basically with this question? Okay, so let's solve it. So basically, the simple way, there are a lot of ways in which you can solve this question. But one simple way is just to do the reduced row echelon form. That just we need to reduce into the upper triangular matrix, look at the particular each and every column and particular hinges. And some books they use hinges and different book refers to different thing. You need to count the independent hinges basically. Okay, so that's all. So we'll be solving using that. So basically, A is given. You need to apply the reduced row echelon form. Okay, so A we know is of the form 3, 1, 2, 2, 0, 5, 1, 2, 3. So this is 3 cross 3 as I mentioned. So basically in those echelon form, you take particular row and try to reduce the different rows either by summing or constantly perform a normal addition or multiplication, subtraction, performance, operation or division, okay, to reduce into the upper triangular matrix. So that's the thing which we need to do. Okay, so first of all, we have been given this is 1, and yeah, if we can get just change the row, that is row 1 with row 3. So this means that just interchange the row 1 and row 3. That is allowed. We can do it. Just remember, you can exchange the rows. You can perform the means operations between the rows to reduce it. So this all are the consonants, basic operation which is allowed us to do it. Okay. After doing this, it will be 1, 2, 3, 2, 0, 5, 1, 3, 1, 2. Okay. Now R3 is equal to R3 sorry for the yeah. Okay. R3 that is the row 3 is equal to row 3 minus perform this operation. What it does become A is 1, 2, 3, 2, 0, 5. The first element becomes 0. The second element is 1 minus 2, that is minus 1. And the third row becomes 3 plus 5, 8. 2 minus 8, that is minus 6. We are able to get 0 here. Okay. Now perform row 2 equal to row 2 minus 2 times of row 1. Perform this operation. It simply becomes 1, 2, 3, 0 minus 4 into 2 minus 1 minus 1 minus 6, 0. So this is my point hinge 1. As I mentioned, you need to count a hinge in each column. Independent hinge. Okay. It will call a hinge if all the elements before it are zeros and it's the first and all the elements to the right side in that particular rows is 0. Just remember this point. The second thing is just basically do one simple operation. Just interchange row 2 with row 3. So that just simply become 1, 2, 3, 0, minus 4, minus 1. Sorry. We are interchanging the row 3, okay, with the row 2 and row 2 with row 3. Minus 1, minus 6, minus 4, minus 1. Okay. So my A becomes 1, 2, 3, 0, minus 1, minus 6, 0, minus 4, minus 1. Now perform row 3 is equal to row 3 minus 4 times of row 2. Okay. So it becomes basically 1, 2, 3, 0, minus 1, minus 6, 0, minus 4, minus minus, that is 0. It becomes, okay. And the third one, it becomes, this element is just simply 1 minus 6 into 4 minus 1 plus 6 4 is 24. Minus minus become plus 24 equal to 23. So these 3 are the hinges. So the answer will be 3. So that's how you need to do the question. Now coming back to question 10th, it's just arithmetic progression, the sum of first n elements. So question 10 is just finding the summation of I from 1 to 120 over I minus 1. Okay. So just you can write it as each and individual term, you can separate it and calculate it individually, basically, so that the problems become easier. Okay. So it's summation 4 I from 1 to 120 minus summation 1 I from 1 to 120. The 4 is a constant here. You can take it out of 4. Summation I from I equal to 1 to 120 minus summation I equal to 1 to 121. 1 is my constant. It can again, you can simplify it as 4. You know that summation of n from I equal to 1 to some element, for example, capital N, okay, can be written as n plus 1 by 2. The normal arithmetic progression, that is n plus 1 by 2. This is all you need basically. So you can write it as n cross 120 into 121 divided by 2, and it's just a summation of constant term up to 120 minus 120. Okay, so I guess you can solve it further. Solve further steps. Okay, so by this, the week 0, we have completed all the questions. Okay, some of the things I skipped because I want you to do it. Okay, because if you be doing it, it will be easy for you. Okay, to follow the content in upcoming weeks. Let's move on to solving the problem from week 1. So first of all, let's see what kind of a problem week 1 is having. Okay. So it's about MP neurons and perceptron algorithms it is covering, and the normal introduction to AI. Okay, so that was the content covered in the week one. And 10 questions again this time out there. So I will be solving the problems. Okay, one by one. If any of you is having any doubt, feel free to ask in between. Okay, week one, problem one. Okay, so basically it requires some brush up of the concepts, whatever have been covered in week one. Okay, so some concept you should be familiar with week one. Okay, so I will be just brushing up some of the things which is required basically. Okay, so that you can easily follow the questions. So MP neurons. Okay, so MP neurons was defined in the first week content. It was the first model in the AI which have been given. Okay, so MP neuron. Okay, so the basic thing is MP neuron is just a binary function which takes decision based on the input it receives. So we have a model. Okay, this consists of two things, G and F. It takes the input x1 till xn. Okay, and gives us the output. All my input xi belongs to the set 0, 1. It's a binary. 0, 1, wherever it comes, it's a binary function. And outputs, which is also a binary function. So you can think it of as taking a decision. Okay, suppose you will go for a movie only if you pass the exam. So passing the exam is just 0 and 1, you can think it of as, and along with that, the parents are happy. So that is again 0 and 1, then only you can go for a movie. So think of it as this model we can have. So the output, how the output is getting calculated in this, it just simply g of x is the summation of each individual unit. Okay, and the decision y depends upon f g of x, where f is my another function which is equivalent to 1 if g of x is greater than equal to theta, 0 otherwise. Otherwise means g of x is less than theta. Theta we call it as threshold basically. Okay. So in different threshold bars and different books and literature refers to different things. Okay. So f is my just a step input function, shifted step. So normal step function, you know that it's normal step function y of x is just simply 1 if x is greater than or equal to 0, 0 if x is less than 0. Okay. When you shift it by theta, that is what this f function is. This is basically step function. Okay, so the decision is just a step function in this case. Okay, so that was needed for the solving the first problem. I assume, okay, yeah. So I will be brushing the concept based on the things we will be needing for solving the problem, basically. Okay, so let's come back to question one. So we have been given a Boolean function. Boolean function means each of its input x of I belongs to set 0, 1. Okay, that's the simple meaning. My function is a Boolean function where each of the input belongs in the set 0, 1 and outputs 0, 1 based on the decision. Okay. They have given some decision boundary. So in the weak one, basically you can think it of as here, this theta as a decision boundary. If my z means f of g of x is greater than theta, I'm saying it to be 1, otherwise 0. So theta is deciding my means what my output will be. So you can think it of as a decision line. Okay. So basically they have given this thing 1, 1. Okay. X1, X2. Okay. Points on the boundary or the light of the boundary is classified as 1. So this area, they are saying it classified as a 1, otherwise this is a 0. Okay, you need one more concept in this. NP neuron was the simplest thing. Let me brush up something related to perceptron as well. So the perceptron is just similar like NP neuron, okay, but with the weight, additional learnable weight, okay, which help in the decision. Okay, so basically you can think it of as we have a neuron. Again, it consists of two parts we can have, but a simple case, let's keep it simple. Okay. Let's keep it simple. We have a neuron which takes the input. Okay. X1, X2 till Xn. Okay. And each of my is having a weight as well associated. This weight are it's not necessary to be integers like 0, 1. It can be any number between any real number. Basically, my weight I can belongs to R. Okay, that is a real number. And this is learnable weights. So you might have heard about optimizing of the optimization means doing optimize means learning the neural network, fine tuning, anything like that. In simple word, it just boils down to learning each and every learnable weight. Okay, so that's the simple thing. So it will be covering up in the upcoming weeks. So just follow the content. Okay. Now my decision is Y. Okay. Again, my decision is a binary decision. That is, my decision is again from in the state 0, 1 because it's a binary thing. Okay. My again, it is 1 or 0. That is a step function means my Y you can think it of as yes or no. Okay. So here the condition is summation of Wi xi from I equal to 1 till n. Otherwise, summation of Wi xi less than 0 if I equal to 1 till n. So 0 is the threshold, and here the bias term theta is minus theta. You can take it off. We have taken as a W0. So for anything, any doubt, you can refer the lecture material because I'm just following the same convention so that you follow the questions basically properly. Okay. So I guess that's it was there. Okay. So let's see the questions. So as I mentioned, they have given this boundary. Okay. And this is active at 1, 0. Once the line, you can see it as of x plus x2 equal to 1. This is the equation for this line. Okay. Now they have asked the question that what does it represent, means for which of the logic gate it represents the decision boundary. Okay, so uh, I think that a lot of might not be knowing about the different gates. So as we have a two input, okay, the gates are just normal binary thing which takes the binary inputs, give a binary outputs, and there's a different logic for each gate. And this is what constitute of the transistors which performs heavy operations in your GPU and CPU and all. Okay. So if any one of them is interested, just go and look in for the logic gates and transistors, little stuff. But AND gate we have. So basically we have a two input, so you can generalize up to arbitrary large number of input as well, the same concept. And means basically in normal mathematical logic, means logics in the mathematics, pure mathematics, it is used when we have been given two sentences and both of them are true, then only the whole and thing is true. So that's the same thing. We have a two input, x1, x2, and we have an output. So the input is 0, 0. It can be 0, 1, 1, 0, 1, 1. If my both are false, output is false. One of them is false, output is false. If both of them are true, then output is true. So basically, if you represent it, if I represent 1 by a cross mark, so it's just 1. Here it's 1 comma 0. Here it's 0 comma 1. 0 comma 0. 1 comma 1. So it's active only for this thing. And it is false for all this thing. Okay. But in the question they have given our bias term was 1. So it can't be an AND gate because for 1 it should be true. Okay. So AND is not a correct answer for that question. The second option was OR gate. So the OR gate is if any one of them is true. I have a two statement. One of them is true. My output is a true. X1, X2, Y. 0, 0. Just remember this combination again for n-dimensional Boolean function. You will be having total number of 2 to the power n combinations. Okay. 1, 0, 1, 1. So basically it's 0, 1, 1, 1. Okay. So I guess this was covered in the week 1 lecture as well, but I'm just brushing up with these concepts. Okay. So if you plot it again like the previous thing, it is active for any of this input is 1 and deactive for rest the cases. So the decision boundary for this, it's the decision boundary for 1. So the correct answer is 1, the OR gate. But two other gates also have been given. So let me write the truth table for that as well, because it might be helpful in the next upcoming questions as well, I think. Okay. So the question was is given is XOR gate basically you want. Okay. The XOR gate basically you can think it of as we are having an input x1, x2, y. It's again 0, 0, 0, 1, 1, 0, 1, 1. It is active only when one of them is active, other one is deactive. So that's how it is defined. Basically, it's 0. So this is the logic gate basically for XOR. And NAND gate is given. Okay. NAND is just simple thing. Just reverse whatever you are getting. And here means not. Okay. So let me add the paper for that as well. x2. Okay, 0, 0, 0, 1, 1, 0, 1, 1, 0. This is normal for no AND gate, which you already are familiar with. NAND gate, just flip the decision. It will be 1, 1, 1, 0. So it's NOT gate plus AND gate. That's what we call it as NAND. Okay. With that, I guess the first problem is solved. We have solved the first problem. Okay, as also you can see that the decision boundary can't represent both of them. It's not possible. So I leave it up to you to argue that why it can't run it. Okay. Coming back to second question. So let's solve the second question now. So in second question is related to MP neuron. So it's just MP neuron they have defined y as 1, 0. Again, a binary output. Binary in 0, 0 and 1. Okay. If x1, x2, x3. Okay, that's my mistake. Okay, so it's just an addition. It's x1 plus x2 plus x3 is greater than 2. 0 if x1 plus x2 plus x3 is less than 2. Otherwise means that gets given as an MP neuron. So it's a multi-correct input and output question. So there are more than one correct answers for this question. Okay. So let's see the option one by one, because it is necessary for this kind of a question. Whenever you have a multiple answer correct, then to go and verify each and every statement. That's how the normal procedure should be done. Option A means is given that y equal to 1 and x1, x2, x3 is 0, 1, 1. If we do the summation of xi, which is 2, and which is greater than or equal to 2, this statement is true. So this option is correct, because my y should be 1 in this case, because summation of x1 plus x2 plus x3 is 2, which is greater than or equivalent to 2. So it's the correct option. Option B, y equal to 0, and they have given x1, x2, x3 as 0, 1, 1, 0, 0, 1. Sorry, my mistake. Okay. The summation of xi in this case is 1, which is less than 2, which implies y is equal to 0, which is again a 2. Okay. So the summation x1 plus x2 plus x3 is 1. Okay. And it is less than 2. So the output is just 0. So again, it's 2. Y equal to 1 and x1, x2, x3 is equal to 1, 1, 1. In this case, summation of xi, that is 1 plus 1 plus 1 equal to 3, which is greater than 2, which implies y is equal to 1, which is again a 2. Okay. So greater than 2. So again, it's a 2 case. Okay. Now, coming back to question, means last option D. They have given y equal to 0 for x1, x2, x3, which is again the combination of x0 is 0, the summation of xi, which is 1, which is less than 2, which imply y equal to 0, which is again a 2. So in this case, all the options are 2. Okay. If you don't want to solve for each and every case, just remember that as just do the summation of x1, xi, basically. Xi, I ranging from 1 to 3, which should be greater than 2, implies pi equal to 1, which again imply that as it's a binary function, which either take, so there should be, it's always, there should be 2 ones in my out input. Okay. Which implies that my out of this x1, x2, x3, at least 2 of them should be on. Okay, on means 1. That's, if you remember this point, you can directly solve the problem. Okay. Now let's come back to question 3. I hope there isn't any doubt till here. Okay. So we are gonna solving the question 3 now. It's again based on MP neuron. So it takes 4 input function, which is x1, x2, x3, x4, and MP neuron with parameter theta. Theta is equal to 2. So the theta, as I mentioned, the shifted version. Okay, let me show you again. Okay, this it's what it's talking about. Okay, g of x. Okay, 2. So they are asking that for how many MP neuron gives y equal to 1. So in the last question, what we solved, it's just the same thing. Here, instead of calculating each and every combination, we just need to use the logic I have given in the last problem. So we know that y is defined as 1 or 0 if summation of xi is greater than 2 and xi is less than 2. So theta was my threshold. As I equal to 4, means total number of input is 4, so they are 2 to the power n equal to 4, sorry, which is 2 to the power 4 is equal to 16 combinations are there. Okay. Now it's asking that for how many MP neurons gives y equal to 1. Okay. For how many inputs, sorry, for how many input MP neurons give 1. So it's basically the threshold is 2. So at least 2 of them should be on. Okay, at least 2 of them should be 1 or greater than, means out of 4, at least 2 of them should be 1. That's it. So the opposite of them is at least, means only one of them is. The total 16 combinations we know are there. Total MP neurons give, means total input is there. Out of that, we need x1, x2, x3. The second equivalent is equivalent to x summation of xi is either 0 or summation of xi equal to 1, because it can't be negative. It's just integer 0 and 1. x4. So basically the combinations are either all 0, 0, zeros, or one of them is 1. These are the 5 combinations. Okay, where after means it is just 10 2, because if we add one of means out of 16, so at least 2 of them should be on. In this, either 0 or one of them is on. Okay, so the answer is basically 16 minus 5, 11. This was the one way of doing. Otherwise, you should have wrote all the 16 combination, sum it up, and see whichever one is greater than or equal to 2. So that's the brute force method. But yeah, that will also work it out. Okay. Now for the fourth problem, it looks interesting. Let's see whether we can solve it or not. So basically, it's about whether we can data point is given, the label is given, and it's asking that whether they are linearly separable or not. That is whether we can run the perceptron such that it classify the all the points either 0 or 1 correctly. Okay, so that's the question basically they're asking. So let me write it down for you. So we have been given x1, x2, and y. So x1 is 2, 4, 1, 3, minus 1, minus 1, 5, 8, minus 1, 2, 0, 1, minus 1, 0, 1, minus 2, minus 2, 1. So this is what they have given. Okay. Let's first of all, like for this question, we need to do plotting. Okay. So plotting is the best method. Okay. We need to plot. Okay. I guess I have lost the notes, but I will be uploading it. Okay. Don't worry. We will have in the question 4. X1, X2, 5, 2, 4, 1, 3, minus 1, minus 1, 5, 6, minus 1, 2, minus 1, 0, 0, 1, minus 2, minus 2, 1. Okay, so this represent the x1, this represent the x2 for us. X1 take 1, 2, 3, 4, 5, minus 1, minus 2. Okay, so and x2 is highest value is 6 and same minus 1, minus 2, 1, 2, 3, 4, 5, 6, 2, 4. Okay, 2 for 2, 4, it is 1, 2, 0. It's also 1, minus 1, 0, minus 1, 0, and minus 2, 2. It is also 1. For this to 4 point, it's 1. For minus 1, it's 3, minus 1, 3, minus 1. It is minus 1, and 5, 6. Okay, 5, 6. It's minus 1. Okay. So what do you think? Whether we can separate it or not? Anyone? Anyone can answer basically this question. Okay. What do you think? Whether we can do this or no? One more detail they have given in the question is that the bias is 0. So the line should pass through the origin. And it's almost impossible to separate this point and this point while having any lines passing through 0. We can separate these two. This is actually the Tillman's actual line, but as the bias is 0, we can't do it. Okay. So I guess the fourth question is also done. Now coming back to question 5th. So again, question 5th is given as we have been given, we need to find the weights. That was the optimal weight at which it will be classifying. And we have been given set of points. So x1, x2, y. x1 is 2, y2 is 2, 2 minus 2, minus 2, 1, 1, 1, minus 1. And initial weight is given as 0, 0. Okay. Now we need to find out what's the when the algorithm converges. So I have hoped that you have went through the means this thing first week. Okay, and you are familiar with the concept of convergence and how to find it, the algorithm. So it has been given as the convergence in algorithm. Okay. So first, how do we proceed in that case? So basically, the algorithm, perceptron learning algorithm is as simple. So these 2 points are positive, and this is negative. Okay. And weight is 0, 0. So basically, we just randomly pick one of the point. That is, I just give it as a P1, P2, P3. Okay. Now P1 is my positive. Okay. And let's check summation of Wixi. This you can also write it as W transpose X, which is 0, which is less than 0. This condition is false. 0 less than 0 is false. So we can't update the weight because the condition should be 2. We have a 2 condition, positive, and the summation of X, Wi plus Xi is less than 0. For positive case, otherwise it's negative. The summation of Wi plus Xi should be greater than or equal to 0. Okay, so we can't. So let's choose another point. Okay, before starting this thing means algorithm, is 0, 0 optimal or no? Let's check it out. In the first case, my summation Wixi is 0. In second case, wi xi is again 0. In third case, again it's 0. So it's not an optimal weight. Okay, it is not optimal. And one exercise which I will be giving you, just plot it and just check whether it's separable or not. Before solving the problem, you should know that the points are separable or not. Okay. So once this is done, we can't update the weight. Okay. Now just check the point P2, which is again positive. And again the summation Wixi. We haven't updated it till that. W transpose X is 0, which is less than 0. Again, this condition is false. Okay. So what we need to do is pick up the third point, which is negative, and summation of Wixi in this case is also 0. Okay, which is greater than or equal to 0. This condition is true. So our weight matrix will be changed at W minus X. So our updated weight will be 0, 0 minus, what was the coordinate for the negative point? It was minus 2 comma 1, which is 2 comma minus 1. So now we need to check whether this point is optimal or not. Okay. In the first case, when our point was 2 comma 2, I guess, no? Let me check it out. It was 2 comma 2. And the way this is was our X, and our weight is 2 comma minus 1. W transpose X is just 4 minus 2, which is 2, which is greater than or equal to 0. That's what we wanted. For the positive point, it should be greater than 0. Second case, X equal to 2 comma minus 2, and our weight is 2 comma minus 1. W transpose X again in this case is 4 plus 2 equal to 6, which is again, yeah, this weight satisfy this thing. Third point, X is equal to this, both were positive point. Okay, which is minus 2 comma 1. Weight is again 2 comma minus 1. So W transpose X is minus 2 into 2 minus 1, 2 comma minus 2 comma 1, yeah, minus 1 equal to minus 5, which is less than 0. So it's negative. So it's optimally converged. So the answer is 2 comma minus 1. Okay. Now coming back to sixth question. So again, it's based on the Perceptron algorithm. Okay. So weight, they have given it as minus 1 comma 0. This is our weight. The hyperplane is this thing. This is our hyperplane. Okay. And they have given the point x1, 2 comma minus 1, some point 0 comma minus 1, either x2, and here 2 comma 1. It's given wrong in the question that 2 comma 1. It should be here in the first quadrant. Okay, so let it be. Now this this is the thing. Okay, we know that the weights perpendicular, this is our decision boundary. Okay, if we calculate this thing, for this point, W transpose X. So it is minus 2 minus 2. It will be minus 2 because the second is 0. Okay. And for this point, it is again minus 2. This point is wrong. Even the question, there is some error in the question in this related to this point is just 2. Okay. So actually x2 is positive because this is a hyperperpendicular. So this whole class should belongs to 1, means 1 class. And this is less than 0. So this is my negative. Negative imply minus 1 as per the convention given. The option is x1 equal to minus 1 and x2 equal to 1. X2 equal to 1. Yeah. That's coming back to 7th question. Now the question is a little bit interesting, but let's figure it out. We can do it. 5 inputs are given. Okay. X1, X2, X3, X4, X5. 5 inputs are given. Binary inputs for MP neurons. Threshold theta is equal to 3. And one thing is given, which is inhibitory input. What does it mean? Whenever it's on, the output is off, irrespective of whatever the other inputs are. Just remember this thing. Okay. The input is given is 1, 1, 1, 0, 1. Okay. If you do the summation of x of I, it comes to 4, and which is greater than theta. Okay. Greater than theta equal to 3. So you might think that it should be 1. Okay, but the answer is no. It's not 1. It's wrong. Because my this input is on, which directly implies that y equal to 0. So that was a little bit tricky question. Okay. Now coming back to question 8, just 3. All of them. Okay. MP neurons take x1 and x2 as an input. In the week, they have some similar question. Say x1, x2 is given, and threshold theta is 0, and it's all. Now, which of the Boolean function does it replace? AND gate. Both of them is on, then only it's on. OR gate, it was 1. So definitely it's not AND, not OR. It's output is 1. And NOR gate, it just, so this, let's see whether what it's about. So again, we have x1, x2, 0, 0, 0, 1, 1, 0, 1, 1. Okay. None all of them is on. 1, 1. So the knot of this is 1, 0, 0, 0. So again, in this scenario, its threshold is 0. So there are multiple answers for this. So the not and all, both of them are the correct answer. So there is some error in the questions. So both of them is correct. Let's coming back to question 9th. Okay. We have been given the weights. Weight is 2 minus 3, 1. Okay. And x is equal to 1, 0, minus 1. So first of all, let's calculate W transpose X, which is 2 minus 1 equal to 1. Okay. And bias is given as minus 2. So it is 1 only when it is greater than a bias. Okay. In which case 1 greater than minus 2. So bias they have given B. So let me check the convention used in the lecture. Okay. Biased, I guess if they have used minus W not as in biased. And W not minus W. So basically it was for the perceptron. For the perceptron, the Y was 1, 0 summation of Wi xi greater than 0. Otherwise, I from 0 to n. So W, you can write it as bias W naught minus 2, 2 minus 3, 1. And X, you can write it as 1, 1, 0, minus 1. Okay, again in this case, W transpose X is minus 2 plus 2 plus 0 minus 1, which is less than 0, which implies the Y is equal to 0. But in this convention, change of convention, Y equal to minus 1. Okay, so the correct answer is minus 1. Output of the perceptron is minus 1 because there was a side change in convention as in the given below. Now coming back to last question, 10th, mentor of AI. Okay, so let's see. I also don't know the correct answer, but I will try to guess is. Let's see. Suppose sometime you don't know the correct answer, then how to make a positive guesses? That also is an important thing. So winter means a normal AI is there. The period during winter when AI technologies are least affected due to cold temperature. Yeah, that can't be the answer at all. Okay, so that's the wrong answer. The phase marked by the decreased funding and interest in AI research. Okay, winter of AI. What does in winter happen? Everything that means you want to do something, you can't go out, something like that happens. So as of now, I think the B is the correct answer for this. The season when AI algorithm perform at its peak efficiency. AI performs in all the seasons, so that also not a correct answer. A period characterized by rapid advancement and breakthrough in AI technologies. That is not in winter AI, that is a boom of AI. That's what is going on. So the correct answer for 10th is option B. That is a phase marked by decreased funding and interest in AI research. Okay, so I guess that's was all the problem from week 0 to 1. I hope you like the today's session. And if you have any question, feel free to reach it out either on the NapTest platform or you can personally ask by my Gmail ID. So yeah, that's it. Happy ending. Yeah.